in clusters or groups that are always naturally occurring, okay, and then selecting a subset of collections and sampling all individuals within the selected cluster. So for us to really appreciate this cluster sampling, I would use an example. For example, Juba. We have many streets in Juba. Because I haven't been there, I would just estimate if you had uh, five streets in Juba, and you wanted now to sample them for your study or for your baseline study about stunting in among children under 5. Having all those streets in that sample would be problematic, but also time consuming. So you can say, because they are naturally occurring clusters, there is, for example, street 1, street 2, street 3, street 4, street 5. Okay, those ones are naturally occurring. They are already clustered. Okay, and they have that level of heterogeneity. Of course, we expect each street to be having uh, men, women of different ages. They can also be having people with disabilities. They also have people of different levels of education and employment, such things, which create that heterogeneity in those clusters in street 1, street 2, street 3, street 4, street 5. So for us to come up with a good representative sample using cluster sampling, we are going to use these five streets to form what we are going to pick from as our sample. So we have street 1, street 2, street 3, up to street 5. So because we want to save resources and time, we are not going to sample from each of these streets. But through random sampling, we can say we are going to sample out only 2 streets out of the 5. So we use simple random sampling and determine which streets can be sampled or they can be used in our sample. So you can use this simple random sampling. You fold your sheets having 1, 2, 3, and up to 5, and then perhaps after your shuffling, you collect street 2 and then street 3 as the ones that you are going to sample. Now, after collecting these 2 options, you are not going to sample again from these 2, but you are going to include everyone from street 2 and everyone from street 3. Okay, so in that case, you would have done cluster sampling. You have street 1 to 5, then you have used simple random selection to get street 2 and 3, and then you have now gone for everyone in street 2 and everyone in street 3 because those are the streets that you considered. So that is all about cluster sampling. The advantages is that it's cost effective, like we are saying, especially if you consider you compare it with the other stratified. Then it can provide also a representative sample because we expect these different clusters to have that heterogeneity or that uh, that diversiveness of the people in each cluster. Then it allows also for hierarchical analysis where individual and cluster level characteristics can be examined. It is almost the same as stratified. And then in the limitations can introduce clustering effects and affect this statistical analysis. It may also result in more significant sampling errors than other methods because, like we are saying, it is just done to save time and money. So in most cases, you might find, yes, you think that one street represents uh, it has characteristics of all the other people, but you might find that one street is also dominated by the same people of the same characteristics. So it could introduce in that sampling error. Then the choice and size of the cluster may influence the variability of the estimates. So you might choose 2 and 3, street 2 and 3, and yet they have fewer people that reside in them, okay? So then you might not use that sample to generalize on the entire population of the people in Juba, okay? Because you have very few people that have been represented in your sample. So that is the limitation of cluster sampling. So as you can see from this infographic or illustration, we have difference between stratified and then random sampling. The circles might not be clear for you, but we are trying to say that if this is the population that you are selecting from, okay, you are selecting from this population here in stratified, you are going to, okay, this is, we are looking at this as the entire population, and in stratified, you are going to go, for example, here, and then you collect these people here because they have the same characteristic. You also go here, you collect these so that you can have that representativeness. While in cluster, you have your clusters naturally occurring, and then you pick either this and this, and then you include all of them in your sample, okay? So that is the difference between stratified and cluster. So the other method, like we said, is the systematic random sampling. We have majorly 4, and the first one was simple random. We had stratified, we had cluster, and then this is another probability sampling method, which is called systematic. And basically here you want to select participants from the population at fixed intervals. That is why they are calling it systematic. And how do you do it? Step number 1 is to define the population of interest. And in our example, we are looking at, for example, the children that are living in Juba and are under 5. Then you determine the desired sample. If you are having 1,000 children that are living there, and you have determined that the sample that you need to represent the entire population will be 100. So you calculate the sampling interval by dividing the total population by the sample size. So in this case, if you have the total population as 1,000, you divide by 100, then your sampling interval there will be 10, okay? Then step number 4 would be now to randomly select a starting point between 1 and the sampling interval. So you again do the other simple random sampling to select the starting point. Yes, I want 100 out of this 1,000. My sampling interval is 10. Like after 10, I should be able to get another person. After the 10th person, I should be able to get another one, okay? So after counting 10, I should arrive to the next person who is going to take part in this study. So you randomly select a starting point between 1 and the sampling interval. So the sampling interval in our case is 10. So we are going to fold our cheats having 1 to 10, and then we can select a starting point. So if we do the shuffling and we get, for example, the starting point to be 2, so now we have 2. If the starting point is 2 and we have our sampling units, the households or the children are listed already, so we are going to say number 2 is going to take part in our study. Now from number 2, we are going to move 10 steps. So from number 2, we shall now go to 11, okay? So 11 would be our second person to take part in this study. So we keep on going until we arrive at 100, until we get 100 people who we had seen as our desired sample size. Okay, so you use that. The whole bottom line here is that you have those fixed intervals, and in this case we have used an interval of 10, which we have arrived at by dividing the entire population by the sampling size. So then, like we are saying, you keep on selecting the case or the 10th individual after that, in our case, until you arrive at your sample size. Okay, we have 1000. We have realized that we need a desired sample size using those sample size determination methods, that we need a sample size of 100. So if we have 1000 as the total population, the desired sample is 100, then our interval would be 10, and then we go on like that to get the required sample. So the advantages is that it is relatively easy and less time consuming, and it ensures coverage of entire population, and then provides a representative sample. But the disadvantages is that there could be a risk of bias if there is a hidden pattern or order in the population. Then it may not be suitable for populations with periodic patterns or clusters. So then you would have to use other methods like the cluster or the stratified. Then if the population list is not randomized, systematic sampling may result in underrepresentation or overrepresentation of certain groups. Yeah, because here, remember, you are selecting people systematically. So imagine if the list is having perhaps some people in one region of that list, like from 90 to 100. That's where the people with disabilities are. Okay, so after that you have people with disability. So you might have underrepresentation of such a group, because through your systematic sampling, you're going to get to represent them when you reach that area where they are written. Okay, after that you cannot get them. Okay, so that is the problem with this systematic random sampling. But to solve that, you can randomize, make sure that they appear everywhere in the on that list, so that there could be a chance of them being selected. Yeah, so that is about probability sampling, whereby everyone has considerably an equal chance of being selected. We had simple random sampling, we had cluster sampling, we had stratified, and then we have winded up with systematic. Now we go to non-probability sampling methods. In this case, it is the opposite of the other, whereby you expect that not everyone will have an equal chance of participation. Okay, so for example, in our first method, convenience sampling, you're going to select individuals based on their accessibility and proximity to the researcher or sampling location. Okay, so you are going to maybe uh, collect your baseline data for an upcoming program in nutrition in Juba. Your office is located on maybe Street 5. So conveniently, you're going to interview people around that street, or and plus the street that is nearby. Okay, so that will be convenience sampling. You just go to those people until you reach the target number or the sample size that you need. So the advantages, as you can see, it's very quick. It is suitable for preliminary research where time and resources are limited. The limitations, of course, is prone to selection bias. Not everyone is able to participate in this case, so that is selection bias. Then results cannot really be used to generalize or to infer to the larger population because you haven't done any representation of everyone, okay? You have just sampled conveniently. So you cannot use such to tell us that you have generalized your results to the larger population. Then we also have purposive sampling, and it comes from that word purpose. So there is a purpose that your study wants to achieve, especially from those objectives that you set. Okay. So if you want to know about stunting among children under 5, so you need to get that data about nutrition. You need to get that data about malnutrition. You need to get data about agriculture, what foods people are eating. So there are those people that you need for your study. Okay, there are those people that are called key informants in this case. Okay, those agricultural officers, for example, in that area that you are going to study or you are going to put your program, those nutritionists, okay, are the people that must be in this study, okay? So you have to purposely select them, okay? So this method involves getting those individuals or choosing those individuals based on specific characteristics or qualities that are relevant to your research objectives. So the steps include defining the research objectives and identifying the characteristics of interest, and then selecting individuals who possess those characteristics. Okay. If you are if your study is about uh, if your study is to deal with the perspectives of people with disabilities on malnutrition, on nutrition programs that have been in that area. Now you are not going to go to these people who are not having those disabilities. You have to focus on only those people who are having disabilities. So the advantage is that it enables targeted sampling of individuals with specific knowledge, expertise, or experiences. Okay. Then it is also useful for qualitative research or when studying unique populations. Okay. And we have talked about such a unique population, but in terms of qualitative research, you are going to get to those people who can tell you a bit more of what you need. Those nutritionists, those agriculturists in this case will have more information than the laymen, than the other ordinary people. So they will give you in-depth information that you will need for your qualitative research. The limitation, of course, is we have subjectivity in participant selection, because you might think that it's only the agriculturists who know about these things to deal with planting, harvesting, and yet there are other people who know. Okay, so that subjectivity might rob you of important information. Then, of course, you cannot depend on only purposive sampling to generalize. Okay, you have to use other methods so as to come up with a better with better results that can be generalized on the entire population. Okay, so that was purposive sampling, and the first one in terms of non-probability was convenience, then purposive, and now we look at snowball. So as the name suggests, as you know what a snowball is, for those who do not know, it's more of a ball that rolls in ice or in snow, And as it keeps on rolling, it keeps on growing bigger and bigger. It starts small, but as it rolls in that snow or ice, it keeps on growing bigger and bigger. It is common in those countries, or in those countries which experience winter. So from that knowledge, you can expect that in this case, if we apply that snowball principle in research or sampling, in this case, we are able to recruit initial participants who meet the study criteria. And then from these initial participants, we get to know the other people that we can go to. So you ask these initial participants, yes, you received these seedlings which are improved so that you can tackle malnutrition in your household. Which other people received the same seedlings? Okay, if you do not have that information, you can ask those people, and then they'll tell you, you got my neighbor, they also received the same seedlings. From the other neighbor, also ask them, which other person do you know? Okay, it can also be in these studies of perhaps diseases. You get some medication, uh, you get some medication for perhaps diabetes. Do you know any other person? Is there any other person that you know who is close by, who also receives or goes with you to the hospital to get that kind of medication? And then they will also give you that information. So you keep on getting more and more participants from the initial people that you get to, and that will enable you to have a large and large sample until you reach, of course, the desired sample that you need. So you keep repeating the process until the desired sample is achieved. Advantage is that is useful in accessing hard to reach populations or individuals with specific characteristics. Okay. Then it facilitates recruitment of participants through social networks because they always know each other. Okay. So those social networks help us to get this sample. The disadvantage is that there could be bias, as participants may refer to individuals with similar characteristics. It is very possible that a person will refer you to the other person who they kind of relate. They also have the similar characteristics. So you might go there and you receive almost the same information as the one that you got from this initial person. Okay, so that will bring in that bias. Then the difficulty in controlling the sample composition, because remember, you're depending on these people who give information about the other people that you have to reach. So controlling who is in your sample or not might be very problematic. You can also not control about, you cannot control the representativeness. You cannot reach on someone and they tell you that the other neighbor also received the seeds, and then because for you wanted the neighbor to be a man, you say, no, I'm not going to interview this person. With snowball, you have to interview that. But by interviewing that person, it could mean that you are going to include in almost the same characteristics which could hinder your representativeness. Okay, so that is snowball sampling, which uh, brings us to the end of our sampling techniques as far as the non-probability sampling is concerned. We had convenience, we had purposive, and then the snowball. So now we need to look at the sample size determination. So how now, after we've looked at how we can get the sample, how really do we now determine the size of the sample that is supposed to be used? Okay, so the importance of a sample size is that it is very essential in obtaining accurate and meaningful results. It is we also recognize that insufficient samples can lead to imprecise estimates, can decrease statistical power, and you also get unreliable findings. So In our example, which where we are looking at 1,000 respondents that we are targeting in that in Juba to assess for stunting among children, if instead of getting 100, which would be perhaps our desired sample size, we got, for example, 10 out of 1,000. That will be a very insufficient sample size. So in this case, it will decrease our statistical power. Okay, we cannot convince people that from these 10 people, the results that we got, we can use them to generalize on the bigger population of the people that are in Juba. Okay, you cannot use 10 people's information to infer or to generalize something that is happening in the bigger in a very big population. Okay, so we realize that optimal sample size depends on factors like research objectives, study design, statistical analysis methods, desired level of precision, and expected effect size. So all these factors come together to make you get uh, a very optimal or a very well defined sample. Okay, those research objectives, how the study is designed, is it cross sectional, is it longitudinal? So you need to know all those factors. You need to know how precise or how much power do I desire for my study, you know. And this could depend on also other factors. It could be the people that will publish it, you know, the effect that it should have on the population, you know, because you do not want to use a sample, and yet you need, for example, if you wanted to stop malnutrition or to stop stunting, you need to use a sample that will make you generate the results that are so good enough that that you can rely on them to put in place an intervention. Okay, you do not want to use a sample that will give you some inaccurate results, and then when you put in your intervention, it also doesn't work. So that is all that you need to know about sampling, sample size determination. So the factors, again here, we look at that effect size, like I was saying. A larger effect size requires a smaller sample size as the difference is easier to detect. If you want if you want to realize a larger effect in the population, for example, the change in malnutrition, you might require a smaller sample size because that change will be very easy to detect. And this can be very relevant, especially if you're doing evaluation studies. Okay, so if there has been a large effect in terms of improving nutrition status, then you do not require a larger sample to know that. You can have a smaller sample size to get that difference. Then statistical power, the power of your research is very important. So if you need a higher statistical power, then you require a larger sample so that you can ensure adequate sensitivity in detecting small or subtle effects. Because if you have a smaller sample, you might not detect those small, very small, or those effects that cannot be detected if you do not have a very large sample. So that is why if you need a larger statistical power, then you require a very large sample. Available resources, now you cannot go for a larger sample um, if you do not have enough resources. Then also the design of your research, like we are saying, is also very crucial. For experimental, it might be hard for you to recruit a lot of people, especially those experiments which are invasive, where you have to inject people, you have to such things, it might not be feasible for you to have a lot of people, okay? And yet in observational, you can observe as many as you can. Then desired confidence level is also a very important factor in medical studies or researches. The confidence level is always like at 99%, while in other social science or community level researches it can be at 95%. And those percentages are really showing that margin of error that a research is able to accommodate, okay? So a higher confidence level, of course, will require a very large sample size so that you reduce that margin of error that you can be able to accommodate in your research. And that also is a very big factor in terms of sample size determination. The margin of error, it defines that acceptable deviation range from the true population parameter. Yes, you have got your stunting among these 100, which there are 100 people that formed your sample, and your level is 90%. But what margin of error did you allow in? Okay, how is it deviating from the entire or the general population statistic? Okay, is what we are calling this margin of error. And then variability in the population, how how different are people in your population, okay? Because if people are highly variable or they are highly different, there are many tribes, there are many religions, uh, there are many races in your population, then you will need a large sample so as to capture or include or represent each and every person in this sample. So the variability is also a very big factor. So the factors that affect the sample size include the effect size or the detectable difference that you need to look at, statistical power, available resources, research design, the desired confidence level, the margin of error, variability of and in the population. So that the formulas that can be used to determine a sample are very many, and they keep on also developing others, but some of them include analyzing power or power analysis, which determines the sample size needed to detect a specified effect size with a given power level. Then the confidence level utilizes those percentages that I showed, and sample size calculators or the software generally utilize statistical formulas and considerations to calculate sample sizes for specific study designs and analysis. So these ones you just punch in what you want, and then they will give you, you punch in the population that you are targeting, whether it's 1,000, you put in the confidence level, you put in the margin of error that you would allow in your study, and then they will give you the sample that you need. Okay. In fact, in this case, you can search about Keish-Leslie's formula of sample size determination, and they will be able to give you that formula which you can use to determine your sample size. So the general guidelines based on experience or prior studies can also be used to determine the sample. So if you have been doing uh, a study amongst children under 5 in Juba, and then you're going to do it again. For example, if you're doing your monitoring and evaluation, you used you did you conducted your survey before you started, you conducted midway, Now, before the end, if you are going to conduct, you do not have to now generate a new sample size. You can use the other sample size that you have been using, and then you get the required sample which you are going to use to evaluate or monitor your program. Then sample size tables are also used in determining sample size. Power analysis also talked about it. Then pilot studies, also almost the same as experience, whereby you have you conduct a preliminary small scale study, and it will help you to estimate what your sample size should be so as to realize your goals. Okay, yeah. So we've been talking about sampling errors, and now it is time for us to go deeper into them. And these are basically uh, inevitable when you are doing research or when you are doing this monitoring and evaluation, and they occur due to natural variation that arises when only a subset of the population is studied rather than the entire population. Like we said, we cannot reach the entire population. We are only able to reach on a subset, which we are calling a sample. And when we do that, these sampling errors are always going to come in. They are just inevitable. So they can lead to biases, and this will affect our validity and generalizability of the research results. There are very many sampling errors that we have, and one of them is random sampling error, which occurs due to chance fluctuation. Like I was saying, not everyone will have a chance of getting selected when you use when you use random sampling. Okay, if you're going to put these cheats in that bucket or whatever you are going to put these cheats in, and you're shuffling, there might be some key populations that you are leaving out, and that will be a cause for that random sampling error. And like we are saying here, those inherent variations in the population causes this error. Okay, you have those variations in the population, but if you are going to use this random sampling, then sometimes these variations might not come out clearly, and yet you need them. Okay, yeah. Then systematic sampling also gives us another error called systematic sampling error, and it is due to the, the biases in sampling and non-response bias. So we said in systematic, you generate you sample and then you determine the interval after which you are going to get another person from the initial. Okay, so you might have gone from number 2 to number 11 because there is that interval of 10. Now when you reach number 11, they do not want to respond. Okay, so you cannot and some people will say, maybe let me now go to number 12, maybe they will respond. But remember, you had set the other predetermined kind of interval. So now when you go to number 12, you can you can bring in that bias. Okay, and when you do not, when you skip this number 11 and now you go to another person, because from number 11 you're supposed to go to perhaps 21. Okay, so if you go to 21, after you've skipped number 11 because they did not respond, that will also lead to another bias which is called non-response bias. But it is all because of this this sampling error that arises from systematic sampling as a method. Okay, so the impact is that of course it affects our findings, the accuracy, precision, and generalizability. Because if we have people not participating, if we have some populations not being represented well, then we cannot generalize our findings to the entire population. We cannot say that the findings that we have reflect what is in the entire population, because then they are not yet accurate enough, okay? And then large sampling errors reduce the reliability. If you say that there was a very big error in my study, then people cannot rely on your estimates. They cannot rely on your study. You cannot inform people using findings out of a study that had a lot of sampling errors, okay? So that's why we always try as much as possible to narrow down or to reduce our sampling errors. Then inadequate sample sizes and bias sampling methods can lead to misleading conclusions. That is also self-explanatory. Then, so for us to minimize, like we have seen, it is not ideal to have them. So we need to minimize them. And how do we do that? We use appropriate sampling techniques, those that bring in all the representatives of the population instead of simple random. You can now go for stratified. Increase your sample size so as to make sure that you have more statistical power, more representation from all the subgroups in the population. Then also you need to implement rigorous sampling protocols and quality control measures. And also, before you roll out your sampling technique, do sensitivity analysis and assess whether this technique will create errors or it will create bias, so that if it does, you implement another alongside it or another, and you leave this that has a lot of errors altogether. Okay. Yeah, so that was sampling error. Then when we look at sampling bias, it occurs when specific individuals in a population are systematically overrepresented or underrepresented. And if this happens, of course, we have uh, problems in our sampling design. It also can occur because of the recruitment process or participant selection methods. So you might hire some research assistants for your study as an M&E professional, and then instead of using these sampling methods, they go out there, especially if you hire those who are natives, they go out there and select people that they know, okay? So if they select people that they know and leave out those that they don't know, you will have this sampling bias, okay? Because in that case, some people might be overrepresented. If they select perhaps their friends or their family friends, then those people will be overrepresented. They could even be having the same characteristic, okay? So it can introduce systematic errors leading to biased estimates and invalid inferences. And the types of this include selection bias, and in which individuals or groups are selected in a way that does not represent the population. And it can arise from self-selection. Uh, in this case, these respondents or the participants in your study select themselves, okay? And this, of course, can lead to that sampling bias, because when they select themselves, then there is that chance, like I was saying, of selecting friends or the people with the same characteristics and leave out the other people who are also needed to form that representativeness of the entire population. Then selection bias can also lead to distorted sample and affect. Whenever there is sampling bias, whenever there is an error in sampling, then you cannot generalize, you cannot convince us that what your findings reflect what is in the population, okay? Because remember, now you haven't represented everyone, okay? Then response bias. is also another form of sampling bias. And in this case, participants might be influenced by factors other than the variables being studied, and it can result from social desirability, which we looked at last time, whereby someone answers or responds to a question so as to make you feel happy, or for you not to judge them harshly. So someone might not be employed, but they will tell you that I'm employed so that you do not look at them in a very bad way. Okay. So that will be social desirability. Then sometimes you might ask them about something and they cannot recall well. So they give you an answer which is inaccurate. And that will be also a part of response bias. Then interviewer bias, sometimes you might want to force them into saying something, or you think what they are saying is not right and you record something which is which is biased, or or leading to that interviewer bias. So someone might be looking like they are employed, and that is what you think as an interviewer. And if they tell you that I'm unemployed, you, because you think they are employed, you write employed, and yet they are unemployed, and that is what they are telling you. So all that can lead to sampling bias. Okay. And of course it will result in inaccurate information. The other one is measurement bias, whereby the data collection method, like we saw the other time, whether it is a survey, whether it is observation, whether it is an interview, whatever you are using can be not accurate enough to represent actual values. And sometimes there could be instrument flaws. Okay, you could be having a recording device, instead of recording the focus group discussion as it took place, it records part of it and leaves out the other. So you might miss out on that information that is very crucial. Okay, so that can also lead to a sampling bias in this case. The impact, like we have been saying, incorrect conclusions, invalid inferences, misleading findings, undermining external validity. Like we are saying, external validity is the fact that you can use your study findings elsewhere in other settings. But if there is bias, you cannot do that. Then these samples which are got in biased or biased samples may not accurately reflect what is in the population. And if this is not controlled, you can lead to ineffective interventions or policies. And this is at the larger level, at the largest level, or the bigger picture that you have to look at. Okay, and that is why we need to not give chance for such bias to prevail whenever we are doing our M&E work. When you do sampling, you should be doing it robustly, because remember, this is going to inform decisions. Okay, you are saying that there is 90% there is 90% stunting, and now you are going to cause alarm. You are going to bring in a lot of people with their interventions to stop this stunting, and yet the data that you collected or the information that you have is inaccurate. So this will be a lot of wasted resources which could be used in another program. Okay, or if you say that it is 10% and people are not going to you have limited resources that are put in place to tackle that, because it isn't of a big deal. In the end, the population that is supposed to gain from your intervention does not gain appropriately. Okay, because you did not get the accurate information. So that is why we always need to focus on eliminating these bias and errors in our researches, because they are going to inform decisions. We are going to use them to influence decisions, policies, and that are put in place in that realm of nutrition and other programs. So strategies again to minimize this is to use appropriate sampling methods. You employ randomization techniques and stratification so that you can have representative samples. Also do rigorous data collection protocols and standardized measurement tools. You shouldn't use recorders that cannot have weak batteries, that cannot be used in those remote settings. Then you should also assess and address potential sources of bias through sensitivity analysis. So before you go to the field to collect this data, you should be able to pretest your methods of data collection so that whatever is the issue, it can be ironed out before you go to the field. Another aspect of sampling is validity and quality assurance. And they are very essential also in ensuring that we have accurate data, we have reliable data, and representativeness during sampling. So when we talk about validation of sampling methods, uh, we are trying to maintain the integrity of this research or this evaluation that we are doing as M&E experts. So validation of sampling methods involves assessing the appropriateness and effectiveness of the chosen sampling method. And you do this, like we have been saying, through pilot studies or simulation exercises. So pilot studies are done before the real study, okay? And simulation, and in pilot studies, you go there. You can go to a few selected households. For example, if you're targeting 100 households, now you can go to maybe 10 and you see how your sampling is working out. Then in simulation, you do not have to go there. You can just use some technological uh, methods, and then you see how it is going to work. Okay, then so you test on a small scale. All these pilot or simulation exercises are tested on a small scale before you go to the bigger scale or to the actual sample that you are going to collect data from. Okay, so it helps to identify the potential biases, what could lead to the bias. Okay, is this question formulated in a way that maybe the respondents are not going to give us answers? Okay, if we are going to use this method, are we going to skip, are we going to represent each and every one? If not, how can we make sure that we improve on that? Okay, so that you use that sampling approach that will help you to generate robust data collection. Okay, so you make those necessary adjustments so as to have a better data collection exercise. So that is all about validity. So you make sure that the methods that you are going to use really are going to enable you to achieve what you want to achieve. Then in quality assurance, you here you want to minimize errors and biases during sampling and ensure adherence to established protocols. And the emphasis is here is to ensure that adherence. Many are times when we go to the field or we send people to the field, but they do not adhere to the established protocols. If I have told you to always skip 10 people, 10 households before you go to the next, because for you you're tired, you want to skip two and you go to the next. So that is where I'm going to now use perhaps some other experts to follow you and see whether you are doing it right. Okay, So nowadays, what these consultancy firms which do research or do monitoring and evaluation, they send research assistants, but also these research assistants are accompanied by neutral or or or, or or other people that are going to verify what they are doing. And this is a process of quality assurance. So it is done to make sure that these people adhere to the established protocols. If we are going to use systematic random sampling, and I want you to skip every 10 households before you get another respondent to interview in terms of malnutrition or stunting, why are you skipping two? And this is where this independent person or this neutral person will come in to say, hey, you are skipping two, and that according to the protocol you are supposed to skip 10. So let's skip 10 and then make sure that we follow the established protocol. So that is all about quality assurance. And those regular checks should be conducted to verify accuracy and completeness of data. After you've collected the data, you should recheck, go through it and see, are there missing values, Are there some questions that I didn't ask, Review those data entry procedures, cross-check the data with source documents, because you might be having a recorder, you have recorded, and then after playing, you are transcribing or you're writing down what they were saying, but you have left out some. So you replay and you see so that you can capture each and everything so as to have better quality, better power of your study. Okay. Then monitoring and auditing is is more of also quality assurance, but in this case, you monitor how things are being done, and auditing involves independent assessment of the sampling process. So it is more of what I was saying earlier on. Then after you've done all this, you need to report now about how you did it. Okay. So reporting will enable us to know what could have gone wrong, or if you did it right and and you captured it or documented it, we can always use that information so as to reproduce the same quality work. Okay, so it is on one hand used to improve the future studies, but on the other, it is used to make sure that we can reproduce the same good work that you did. So that is what we call reporting and documentation about their sampling techniques. Then there are a lot of sampling software and tools. So these ones we are just going to rush through them. So they are generally what enable us to, first of all, come up with samples. Second, to see perhaps if we need a sampling interval, how would we do that? Then they can also help us to collect data itself. They can also help us to clean it, but also analyze the data and give that information that we need. Okay. So if you go to the field, you collect a lot of data about employment, tribe, uh, education, marital status, all that, religion, all that, the nutrition levels. That is a lot of data. So you need to analyze it so that you can come up with things that can make a lot of sense, or what is regarded as information, especially to those stakeholders. So the stakeholders do not need to know a lot of all those figures. They just need to know what is now the level of malnutrition in our area. Okay? Amongst the employed, how many of their children are malnourished? So all that is very possible if you use these sampling softwares, which first of all will give you the sample, will enable you to generate sampling interval in case you're going to use systematic. Then they will also enable you to clean your data, to collect it, to clean it, and then analyze it. So there are very many statistical software packages, and these include R, SAS, SPSS, or statistical package for social sciences, which, by the way, is most common. Then we have EPSEM, which is also more of a sampling specific software that will enable you to that will enable you to engage in sampling, which is a bit complex. And then Winbags, we have Qualtrics, which can be done online. We have SurveyMonkey, which is very common nowadays to do those online surveys. And then the data collection tools, which include RedCap, we have Open Data Kit or ODK, we have Kobo Collect, and very many others. So these generally help us to collect data, to come up with samples, to clean the data, to analyze it. Okay, so there are very many, and as you go on, especially to do the practical bit, you're going to see how to use these techniques or tools. So that has been it for today. I know it has been quite long because also the content was a bit novel or new, and also we had a lot of slides. But I thank you so much for being patient with us today, where we looked at the different methods of sampling, and we also looked at what could cause sampling errors and biases and how to limit such.
Then you close the door, okay?
And we also gave a brief highlight about the different tools we can use in sampling, in data collection, and in analysis. So that has been it from me, and I think now I can receive a few two questions, and we call it a day. Any question? I think we are having only one student left. Yes, Okelo, do we have any question from you?